Good day viewers, you're welcome back to Shabes online tutorial. In today's tutorial, we're going to learn how to use separation of variable to solve a differential equation. If you are new here, consider subscribing to my channel and also follow me on Facebook, TikTok, Instagram at Shabes online tutorial. So the question on the board, we're asked to solve this equation x plus 1 dy minus y dx is equal to 0. And when you are given a differential equation, it can be solved using separation of variable if and only if the equation can be written in the form dy over dx is equal to g of x multiplied by h of y. So you can use any variable to represent it. If the equation can be written in this form, that means it can be solved using separation of variable, or otherwise you think of another method of differential equation to solve the problem. Now let us see our given equation whether it can be written in the form g of s multiplied by h or y. This means that some times of x we separate it from y. Let's see if it can be easily separated, or otherwise we think of using another method. So let us see the differential equation. We're having a x plus 1, then dy, then minus y dx is equal to 0. So the first thing we are going to do is to divide through by dx. So we are going to divide through by dx, then dx, then over dx, so that this dx is going to cancel this dx. So we're going to have what? X plus 1 dy over ds minus, this place remain only y, which is equal to 0 divided by dx is going to be 0. Now the next thing we are going to do, remember, look at in this form, dy over ds is the subject of the formula. Also, we are going to make dy over ds to be the subject of the formula. So the first thing, let us move this minus 1 to the right hand side of this equation. So I'm going to have what? X plus 1 multiplied by dy over ds, which is equal to, taking this one to the other side of the equation, is going to be plus y. Now we are looking for, our interest is to make dy over dx to stand alone in this left hand side. Now we're going to divide what? Divide through by x plus 1, then over what? X plus 1, so that this x plus 1 will cancel this x plus 1. We have left with what? Dy over ds, which is equal to y over x plus 1. And this y over x plus 1 can be written as what? 1 over x plus 1, then multiply by y. So if you multiply 1 by y, it will still give us back this. So if you can see this function, it is successfully separated. This is 1 over x plus 1 in terms of x, then multiply by h of y, y in terms of h of y. So this given differential equation can be solved using separation of variable. So now that we know that this equation can be separated, now we can work ahead to solve using separation of variable. What are we going to do? The first thing we are going to do is to cross multiply. So cross multiplication, we are going to have x plus 1 multiplied by dy is going to give us what? S plus 1 dy, which is equal to the x multiplied by 1 multiplied by y is going to give us y dx. And the only problem here, if you look at this equation, x supposed to connect with the x, then y supposed to connect with the y. So we are going to rearrange them. We are going to make the x in x. So we are going to make x to connect with the x and y to connect with the y. So how are we going to do? First thing to do is to divide through by x minus 1, and also we divide through by y. So we're going to have what? X plus 1, then divided by what? X plus 1. So x plus 1 will cancel x plus 1. It will be 1, right? It's going to be 1 dy, which is equal to, then y over x plus 1 is this instant. So we are going to have y dx over x plus 1. Now the next thing to do is to divide through by y, because we're going to move this y to the other side of the equation. is going to be what? Y, which is equal to also y. So that this y will cancel this y. We have left with only 1 in the numerator. So this function is going to be what? 1 over y dy, which is equal to what? 1 over x plus 1 dx. So we have successfully connect y with dy and also x with ds. Now, the next thing we are going to do is to integrate both sides of this equation. So I'm going to have an integral of 1 over y dy, which is equal to what? Integral of 1 over x plus 1 dx. So let us integrate. Integral of 1 over y is going to give us what? Ln of absolute value of y, which is equal to integral of 1 over x plus 1 is going to give us what? Ln of absolute value of what? 1 over x plus 1, then plus integration constant. So now we have successfully integrate. Now the next thing we are going to do, to remove this ln, recall your calculus. We are going to multiply through by exponential in order to cancel out the ln. So I'm going to have what? Exponential ln absolute value of y, which is equal to exponential ln absolute value of 1 over x plus 1, then plus integration constant. Now we notice that exponential can cancel out exponential. So in this left answer, we are left with only what? Absolute value of y, which is equal to, this is plus. According to law of indices, this can also be written as exponential of ln absolute value of 1 over x plus 1, then multiply by what? Multiply by exponential raised to the power of constant. So in this case, we are going to have what? Absolute value of y, of course, is positive, is going to be y, which is equal to exponential will cancel ln. So we have left with what? Absolute value of 1 over x plus 1. Then multiply by what? Multiply by exponential raised to the constant is still constant. So multiply by constant. So y now will be equal to absolute value of 1 over x plus 1. If we are taking absolute value, it's going to give us two values. So this is going to be what? Plus or minus into the bracket of 1 over x plus 1, then multiply by what? Constant. So this is the value of y in this differential equation using the method of separable. Thanks for watching, and please don't forget to subscribe to my YouTube channel. Also follow me on Facebook, TikTok, Instagram at Shabes Online Tutorial.